Hello, in this video I will talk about an interesting portion from microbiology, which is screening and production of antibacterial agent. We all know that microbes are a source of different important proteins, enzymes or antibacterial agent. After the isolate is characterized and we furnish all the details about the microbe or microorganism or the isolate, and if we plan to extract enzyme or antibacterial agent from that specific isolate, it is important to screen this microorganism, or a screening step is important before actual production of this antibacterial agent. So in this video I will talk about how we do screening of this microbes for antibacterial production, for this production of enzymes. Let's talk about this. So as you can see in this picture, primary screening for antibiotics. Isolate, which is the microorganism, were perpendicularly streaked on a nutrient agar plate which is supplemented with 1% twin 20. So if the isolate is streaked perpendicularly on this nutrient agar plate supplemented with 1% twin 20, if we find the zone of hydrolysis around this isolate, then we can confirm ourselves that this isolate is ready or is able to produce antibiotics, and that is how we do primary screening for antibiotics. Secondary metabolite extraction. Isolates which show positive result in primary screening for antibiotics, as I have discussed earlier, were now selected for fermentation, and this fermentation is called a submerged fermentation. It is carried in starch casein medium maintaining pH 7.2 in a flask. This is a pilot scale project in a conical flask in aseptic condition. Flask then kept on flask shaker for 1 week at a period of at a speed of 100 rpm at room temperature. So after the fermentation, automatically the medium will turn turbid. The medium now to be centrifuged to remove the cell and the debris. The supernatant collected, an equal volume of ethyl acetate is added to extract secondary metabolite. So isolates that have shown positive result in primary screening now are kept for fermentation in a starch casein medium. So after fermentation, the medium will turn turbid because of the enzyme production in it. So once the enzyme is produced, there is no need of or no requirement of the cells, so the cells are removed by centrifugation, and the supernatant is collected and equal volume of ethyl acetate is added to extract the secondary metabolite. Secondary screening for antibacterial activity. as you can see in this picture. The secondary metabolite obtained, that is after fermentation, were screened for antibacterial activity against selected gram-negative microbe. The antibiotic sensitivity is determined by standard disk diffusion method against many antibiotics. The antibacterial activity is performed on Mueller-Hinton agar using diffusion method. You see, zone of hydrolysis is found around the secondary metabolite that is extracted from the isolate by submerged fermentation and centrifugation. So this zone of hydrolysis indicates that this isolate is capable to produce antibacterial activity and the secondary screening is positive. So this is actually I will talk in detail about this secondary screening for antibacterial activity in my next video. This is a Mueller-Hinton agar and these are discs. So this method is called as disk diffusion method. And different gram-negative bacteria are plated in this Mueller-Hinton agar to check the antibacterial activity of the secondary metabolite that is produced from the isolate.